Good afternoon, everybody. Let me just quickly introduce myself. So I'm Ralf, 7 years in the industry now, working for Siegwerk. I'm a chemist by education, and since 3 years, I'm basically taking care of our sales for UV inkjet inks in Europe, Middle East, and Africa. So happy to tell you something about UV inkjet in packaging and labels. It will be a bit more general also about inkjet in packaging and labels with a focus on UV technology. So let's maybe start with a very familiar picture for probably everybody in this room. So walking down the aisle of a supermarket. A lot of you are packaging professionals, but in case you are not, it's quite easy to overlook the complexity of the products in the shelves. Because in each aisle, usually you find a whole mix of plastic, paper, glass, metal packaging, which all have their specific requirements and demands in terms of print performance and overall packaging performance. And this complexity is basically our daily business at Siegwerk. So we are one of the major ink manufacturers specifically for the packaging and label markets. So basically we are looking back on a history already of 190 years, and we have a global output of conventional inks of more than 280,000 tons per year. Quite important always for us to mention, we are focusing on solutions and not on products, because to address really the complexity in packaging printing, standard products are not enough, but we really target customized solutions for each application. So we are organized in a business unit structure. So basically you can see here, the business units itself, they are organized again by the final packaging applications. And that's basically here where the 280,000 tons are. And then in 2018, we had a baby called inkjet. So basically, we created the inkjet business unit following the acquisition of the UV inkjet ink business for single-pass packaging and label applications from the company Agfa. And that's basically when our journey in inkjet started. So to be more precise, that's basically what we focus our inkjet activities on. So we are always talking about drop-on-demand inkjet for piezoelectronic systems being used on single-pass machines for printing, packaging, and labels specifically. So in general, we believe that the whole diversity and complexity in packaging and labels cannot be addressed with a single ink technology, but you need UV and water-based inkjet to be successful in the end. Why? So basically UV, it's the perfect technology if you want a glossy print, if you want bright colors, resistant print as well. It's quite easy to use, it's super stable on the press, there's nothing in the ink which evaporates, so the latency of the ink is really high. You can basically have your UV inkjet system on standby for days or weeks, and if you start it again, the first or usually at least the second print should be good. However, there are, let's say, two main technical drawbacks in UV technology. We already heard it, it's migration. It's probably not a big surprise to everyone here. So UV formulations, they consist of quite hazardous chemicals and reactive chemicals. We have photoinitiators. If when they react, they break down into even smaller molecules, which then are quite easy to migrate out of the polymerized ink film. We have reactive monomers and oligomers, which are also still small molecules, and if they are not fully cured, you have some free monomers remaining, which then also will migrate out of the polymerized ink film. So if you are talking about sensitive applications, nutrition, pharma, healthcare, packaging, and you are not able to provide a perfect barrier, then UV technology is probably not the right choice. Same is basically for very thin substrates. So for a UV ink, basically the one main point is that after curing, so 100% of the, not the volume, but the mass you applied as a wet ink will remain as a dry ink. So nothing is evaporating. You're just converting it chemically from wet to dry. If you are now printing, let's say, an average layer of 10 to 15 micrometers of wet ink and you cure it, you end up with 10 to 15 micrometer of polymerized ink film. If now you're doing that on a very thin substrate, your ink film can be as thick or even thicker as your substrate, and of course you're completely changing the performance of your film. So for sensitive applications as well as for very thin substrates, water-based technology will be most likely the better choice if it's technically feasible, because we know that water-based is still in a very early stage if you're not applying it on absorbent porous structures like paper-based materials. So our most relevant application segments where today we are commercial with UV and water, they are basically 4 UV segments, so labels, coding and marking, direct to shape, and pharma applications. And then in water-based, we are mainly focusing our efforts on absorbent substrates, tissues, napkins, and we are, like a lot of other people, investing a lot of R&D effort in finding the solution for flexible packaging. So our setup is quite nicely matching with basically what you see today in the market being actually used in terms of inkjet printing in packaging and labels. So basically here you just see a snapshot of the installed presses, UV versus water-based. And basically you can see that UV inkjet, of course it's primarily used in labels and coding and marking. That's just today the main sweet spots. But overall we see UV predominantly in narrow web applications. So speaking of, say, web width of 30 or 40 centimeters and below, while water-based is more present and growing in the large width applications, folding carton, corrugated, of course, flexible packaging if it's possible, and tissue. So what are the driving forces in today's packaging market? And you cannot imagine how relieved I am that basically this slide is matching with what Joe has said. So let me just quickly go through these. So basically it's diversification. I mean, long runs converting into more and more short runs because brand owners are looking for, say, a competitive edge. Tight management of working capital. We minimize stock, minimize waste, and minimize the time to market. Sustainability, we need to go to a more circular economy, move away from the linearity which we still have today. We have increasing regulatory pressure, then again leading to increasing demands in terms of traceability on the packaging that we produce, and the talent management. So we have a shortage of print technologist profiles because less and less young people want to get their hands dirty with ink operating a printing press. So how can inkjet support these trends? So let's just look at a couple of these. So most prominently, I mean, inkjet offers a cost advantage for short runs. Probably nobody's surprised here. We don't need to prepare a print object like we have to do in Gravure or in Flexo, so we don't need to amortize our cost. Each print costs the same. So for short runs, inkjet can be cost efficient. And what's the most extreme short run? It's basically coding and marking. So we have basically each print really being different, and especially with UV inkjet technology, coding and marking became pretty easy because nowadays you can basically have a monochrome print bar consisting of one print head, a small LED unit, for a really affordable price, which you can basically integrate in your packaging line and efficiently do serialization, traceability on your production. Apart from that, inkjet as a non-impact technology offers new possibilities in terms of direct-to-object or direct-to-shape printing, which can be a very lean process. It can help to save energy, save materials, if it's used correctly, because it's good if you use it on reusable materials. It's maybe not a good idea to print directly on a PET bottle, which will kill basically the one efficiently working recycling stream which today we have. So de-inking options will be quite important to, let's say, increase the reach of direct-to-shape technology in the near future. Decentralization, we had it before, basically to what we also can call late-stage customization, so to apply variable data in line in your, or at the end of line of your production line, for example, to get rid of all of these different language ingredients, text, to save inventory, to save material. And also for the talent management, what digital can deliver is basically bringing or requiring more IT skills rather than mechanical skills, which might attract more people, more younger people today to step into the role of a press operator. So it looks like inkjet is perfectly set to meet all the requirements of the trends and drivers in the packaging market today. So what are the challenges specifically for UV inkjet, just to mention at the end. So just a couple of basically product safety aspects. As I mentioned it before, if you are operating in a sensitive environment, you need to make sure that the final consumers are protected, that you basically can minimize or exclude any hazardous migration. However, what a lot of people tend to ignore is we don't only have to protect the final consumer, but also the one handling the ink, being the press operator. So we are part of the OIPIA organization, and therefore we are committed to not use any CMR components in our inks, so nothing which is categorized as cancerogenic, mutagenic, and reprotoxic. So we are constantly monitoring basically the regulatory developments, and then we are phasing out materials of which we know that soon they will be reclassified in the CMR category, which is a constant journey. Substrate complexity, as I said before, we can customize the ink to make it work on different substrates. However, changing the ink on an inkjet press is much more complex and time-consuming than doing it, for example, on a flexo or on a gravure press. So you might not want to have multiple different inks for different jobs, but enablers like primers and varnishes, jettable or analog, in my point of view, will play a key role in basically managing complexity of packaging market printing application. And then last but not least, special effects. So especially in the label segment, where UV inkjet is today strongly competing with UV flexo, a label converter is basically used to apply special effects on a regular, if not daily basis. So basically you have metallic effects, haptic, optic effects, specialties like scratch-off inks for lottery tickets, rub and sniff inks for perfume catalogs, which are still existing. And there is still today a quite significant gap, and a lot of these specialties are just technically not possible today because of nozzle size restrictions or the restrictions that come basically with dispersing big particles in liquids. But we are constantly working on that, and just to close the talk with a bit of personal advertisement, we recently launched a first jettable matte varnish based basically on UV technology, which we developed together with Zyco and integration technology. So if you have any questions to that or to basically everything which I said in the last good 15 minutes, feel free to do it in the coffee break. Thanks.